All right, let's take a look at section 12.3 on geometric sequences. All right, first I kind of want to start off by comparing arithmetic sequences to these geometric sequences. Now, recall that in arithmetic sequences, we would get to the next term by adding a common difference that we refer to as d. Now, for the geometric sequences, we are now going to get to the next term by multiplying by a common ratio, and we will call that r. All right, looking at the sequence right here, 5, 7, 9, 11. Looks like each time I am adding by 2 to get to my next term. So this must be an arithmetic sequence with a common difference of 2. All right, now if for some reason you didn't just notice the pattern of plus 2, since the opposite of adding is subtracting, you could technically just take any term and subtract the previous term to get the common difference. So I could take 7 minus 5 and get 2. 9 minus 7 and get 2. 11 minus 9 and get 2. You get the idea. Let's take a look at how that works in a geometric sequence. So here we have a geometric sequence, and you can tell to get to each next term, I multiply by 2, multiply by 2, multiply by 2. All right, it's definitely geometric because I have a common ratio or an r of 2 between every term. Now, again, if I wanted to see that via formula, the opposite of multiplying is dividing. So if I divide any term by its previous term, I will always get my common ratio. 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 20 is 2. You get the idea. All right, this is a little bit tougher. I am telling you it's a geometric sequence, but what is the common ratio? 5 times what gets me here, times what gets me here, times what gets me here. If you can tell and you said the answer was 2/3, you're correct. Now, if it's not, just doesn't jump out at you, why don't you try and divide any term by its previous term? So for example, why don't we take 10/3 and divide it by 5? When I do that, I'll use keep, change, flip. So I'll actually flip my 5 into a 1/5 and do 10/3 times 1/5. If I multiply that out, multiply the top, I get 10 times 1 is 10. 3 times 5 is 15. 10/15 simplifies to 2/3, which is my common ratio. Now, I could have done any two terms. So I could have done 29ths divided by 10/3 or 40/27ths divided by 29ths, and I would still get that common ratio of 2/3. It's a good way to do it. All right, take the time right now to copy down your green definition box on page 533 and to read through example 1 on page 533. Go ahead and pause this video if you need more time. I'm going to advance to the next slide. For these 6 sequences, my first question is, are they geometric? If the answer is yes, please give the next term and the common ratio. All right, so first, is it geometric? If it is, what's the next term? And what is the common ratio? Go ahead and pause this video, answer these questions, and then I will reveal the answers. All right, and check your work. If you have any questions, please comment or email or Google Classroom message me. All right, now I would like you to simplify these 4 expressions. And we're going to go through these one at a time, but if you want to pause the video and do your work, and then you can resume. Let's take a look at number 1. X to the 8th times x squared. Multiplying like bases, so I'm going to add the exponent. If you said x to the 10th, correct. Same thing, number 2, multiplying like bases. Let's add the exponents. That would be n to the 4th power. All right, do we remember what to do with our negative exponent? This means if I'm in the numerator, I'm going to move this down to the denominator. So now I should have 1 over x for number 3. Very good. All right, number 4, negative exponent with a fraction. I'm just going to go ahead and flip my entire fraction and then raise it to the positive power of 1, which means I have 3 over 1 to the 1st power, or just 3. Final answer. All right, again, any questions, please comment or Google Classroom message me. All right, please take the time at this point to copy down your 3 geometric sequence formulas, which are on pages 533 to 534. Make sure you get your recursive formula, your explicit, and your generalized explicit. Pause the slide if you need more time because I'm about to advance. All right, let's go ahead together and take a look at example 2 from page 534 at this time. All right, if you are following along in your book, I'm on page 534, and example 2 reads, write both a recursive formula and a simplified explicit formula for the geometric sequence 4, 2, 1, ... All right, so first of all, I just want to identify some of my key pieces. I already know it's geometric, so I'm just going to take the time to write out what my first term is, which is 4. All right, next thing I'd like to identify is what is my common ratio, or my R. So how do I get from 4 to 2 to 1? Looks like I'm multiplying by a fraction. So if I'm not sure what fraction, I'll take any term and divide it by the previous one. So I could take 2 and divide it by 4. All right, that would give me 1/2. Or I could take 1 and divide it by 2. That would give me 1/2. So in other words, no matter what I do, R is 1/2. So here's my important information. First term is 4. Common ratio is 1/2. All right, let's focus on the recursive formula first. Now, I went ahead and got this definition right out of my book. The recursive formula is a sub n equals r times a sub n minus 1, where a sub 1 is given. All right, and we know in this case that our a sub 1 is 4. All right, my goal is to fill in both my r and my a sub 1. So if I rewrite my formula, a sub n equals 1/2 times a sub n minus 1, where a sub 1 equals 4, that's my answer. Recursive formula, no problem. All right, let's do explicit. To find the explicit formula, I went ahead and got this formula right from the book. It's the explicit formula for geometric sequences, and this is the one where you know the first term. Now, just like in my recursive formula, I'm going to fill in my r and my first term, my r and my first term. Okay, so let's go ahead and do that. All right, so I have a sub n equals a sub 1, which is 4, times r, which is 1/2, to the power of n minus 1. Okay, this is where it gets a little tricky. If you wondered why I had you suffer through that Khan Academy recently, this is why. Because I was having you practice for your exponents. All right, let's go ahead and split up. I'm going to keep the 4. Instead of keeping this 1/2 to the power of n minus 1, I'm going to rewrite this as 1/2 to the n power times 1/2 to the negative 1 power. Now, I'm always allowed to do this because think about it. When you multiply like bases, you would add the exponents, which means this would simplify to 1/2 to the power of n minus 1. I kind of just went backwards with it. All right, now once I did that, what does 1/2 to the negative 1 power simplify to? My fraction's going to flip, and it's going to be 2 over 1 to the first power. 2 to the first power is 2. So now I'm at the point where I have a 4 times a 1/2 raised to the n power times a 2. Let's go ahead and multiply the 4 times the 2. My final answer is going to be 8 times 1/2 to the n power. That is my simplified explicit formula, and I do want you to take the time to simplify these formulas. All right, let's go ahead and move to the next example. Actually, before we move on to the next example, I'm going to give you 3 problems to try on your own. Feel free to do this on a whiteboard for memory's sake, or to do it right in your notes so you have examples for yourself. What I'd like you to do is go ahead and jot down the question, and then pause this video, answer it, and then I'm going to reveal the answer. But I do want you to write both a recursive formula and a simplified explicit formula for each of these geometric sequences. The first one I'm giving you is the first term is 6, and the common ratio is -2. So pause your video. Here comes the answer. Okay, here's the answer to problem 2a. Recursive formula a sub n equals -2 times a to the a sub n minus 1, where a sub 1 equals 6. The explicit formula answer is this one right here. A sub n equals -3 times the quantity of -2 to the n power. Now, if you had this answer below, you are correct so far, but you need to take the next step and simplify that explicit formula so that you'll end up with -3 times the quantity of -2 to the n power. I just wanted to show you this so you know that you're on the right track. All right, let's try the next one. Here is problem 2b. This time you're going to have to go ahead and extract your first term and your common ratio, and then use your formulas so you can write your recursive formula and your simplified explicit formula. Pause the video. Here's the answer. Okay, go ahead and check your answers for 2b. There's the recursive formula, a sub n equals 3 times the previous term, where a sub 1 equals 4. Your explicit formula should be a sub n equals 4/3 times the quantity of 3 to the n power. If you had this answer below, you're on the right track, but you still need to take those steps to simplify to get to that final answer. All right, one more to try on your own. Same directions for problem 2c. The sequence is 45, -15, and 5. Go ahead and get both those formulas. Pause the video. Here comes the answer. Please check your work to 2c. Recursive formula, a sub n equals -1/3 times the previous term, where the first term equals 45. And the explicit formula, simplified, a sub n equals -135 times the quantity of -1/3 to the nth power. All right, let's go into example 3 together. All right, we are up to example 3, and we are finding an explicit formula if my third term is 7 and my fifth term is 28. Now, just like before with our arithmetic sequences, same thing with the geometric sequences. If you don't know the first term, you want to use this generalized formula. So I went ahead and wrote the generalized formula. Now, some people are going to choose to figure out R on their own, work backwards, find the first term, and go back to that other formula. That's fine, but I want to work this example through with the generalized formula, which would be like a logical approach here. Now, as I approach this formula, I put this note for you. If you make n the term with the larger subscript, it's just going to make your life easier, because after all, you're subtracting n minus k. So let's see, my larger subscript, 3 versus 5, here's my larger subscript, the 5. So I'm going to go ahead and make my n5, which means my a sub n is 28. So if that's my n, then this is my k, 3, which means my a sub k equals 7. All right, let's go ahead and use our formula, and we really need to find r before I can even come up with a formula. So let's see if we can fill in all these pieces and find r. So a sub n is 28 equals a sub k, that's 7. We're looking for r. I'm just going to leave r. I don't know that yet. N minus k is 5 minus 3. Okay, so that means that 28 equals 7 times r to the second power. All right, I want to get this r alone. Let me go ahead and divide both sides by 7. So that's 4 equals r squared. Oh no, Radical Man is back. We need to remember, if I'm going to take the square root of both sides, I need a plus or minus. So r could equal plus or minus 2. So my common ratio might be positive 2, might be negative 2. Either one would work. You can actually pick either one in this case. For my purposes, I'm just going to go ahead and use r equals 2 for this example. You would still get it right if you chose to make r equal to -2. Totally your call. All right, let's grab our formula again. So I have my setup here, and my final answer needs to have an a sub n in it. It needs to have an n in it. So I'm going to go ahead and fill in my a sub k. I'm going to fill in my r. I'm going to fill in my k and see if I can come up with this formula. So a sub n equals, what was my a sub k? 7. Times, what's my r? I'm going to choose to use positive 2. Times n minus, what was my k? 3. All right. Bunch of algebra classes would accept this as their final answer. I want you guys to go ahead and simplify this. So let's keep going here. So I'm going to make this 7 times 2 to the n power times 2 to the -3rd power. Because remember, if we're multiplying like bases, sorry, there's a glare there. If we're multiplying like bases, this would be the same thing as 2 to the power of n minus 3. Add the exponents. So I just separated it out. Now, what does 2 to the -3 power equal? Let's go ahead and write that out so we can see it. That means I would have to flip this to the bottom, right? And make it 1 over 2 to the 3rd power. It's a good way to see it. 2 to the 3rd power is 8. It's So that would be 1 over 8 or 1/8. Now I'm going to combine these. 7 times 1/8 is equal to 7/8 times 2 to the nth power. Final answer, simplified explicit formula for example 3. Moving on to example 4. Find two geometric means between 3 and -24. There is a definition for geometric mean on page 535 at the top. The terms between two given terms of a geometric sequence are called geometric means. Works just like arithmetic means, but you're multiplying to get to the next number. So in this case, we're going to have a 3, something, something, and a -24, which means I know my first term is 3. I don't know my second term. I don't know my third term. My fourth term is -24. Now, let's do this just like we work the arithmetic mean problems. We can use our easier formula because we know our first term. We need to find r, then we can just use r to get all of our answers. All right, so let's see. How do we want to do this here? Why don't we make n equal to 4? And why don't we make a sub 4 equal to -24? And that way we can plug in 4s for all of our n's. So I'm going to say that a sub 4 equals a sub 1, which is 3, times r I'm looking for, and I made 4 minus 1. Okay, so what was a sub 4? -24. So -24 equals 3 times r to the third power. All right, we need to isolate this r, so let's go ahead and divide by 3. So -8 equals r cubed. All right, how do I get rid of a cubed? I take the cube root. I need to take the cube root of -8 here. If you are using your calculator for this one, if you go to the math category, you will see cube root. It's the fourth item down. So you can take the cube root of -8. Now the cube root of -8, what number times itself 3 times equals -8? It's going to be -2. It is not plus or minus. It's just -2. Because -2 times -2 times -2 will give you -8. So -2 equals r. Now that I have my r, this problem is going to be so easy. Let's go up to our sequence here, and let's multiply by -2. 3 times -2 is -6. Let's multiply by -2 again. -6 times -2 is 12. Let's multiply by -2 one more time to see if it works. 12 times -2 is -24. Definitely works. My answers are, the two geometric means are -6 and 12. That is the answer to example 4. We're going to do one final example together, then I'm going to have you practice a couple questions, and you are done lesson 12.3. All right, let's do our last example. Example 4 is very similar to example 3. We're going to find the geometric mean, so that's just 1. So instead of the, it might even just say find 1 geometric mean between 5 and 45. There is a shortcut when you're only looking for that one middle geometric mean. It's on page 535, right between examples 5 and 6. You're welcome to look at that and use that shortcut if you prefer. I'm going to just do it the normal way. So if I'm looking for one geometric mean, I know my first term and I know my third term. It's 5 and 45. I am missing my second term. So that means that n in my case is 3 and a sub n is 45. Let's go ahead and find r in our formula. A sub n is 45. A sub 1, 5 times r to the power of what's n? 3 minus 1, 45 equals 5 times r squared. Let's isolate that r squared, so let's divide by 5. 9 equals r squared. Oh, here comes radical man. So when I take the square root, r could technically be plus or minus 3. Wow, so there's actually two different correct answers for this one. If I choose to use positive 3, and I multiply by 3 here, times positive 3, I'm going to get 15 times positive 3 again, brings me to 45. So 15 is a correct answer. If you decide that you want to use -3, 5 times -3 is -15, times -3 is 45. So you may get 15 or -15 as your answer. You don't have to give me both. You can pick one or the other is fine. All right, let me give you a couple problems to try on your own. All right, you are on your final four. I know it's no longer March, but we're doing the final four right here. So first question, find one geometric mean between 7 and 28. I'm going to ask you to go ahead and pause this, do the work, and that way you can get the answer as soon as you come back. And here it is. You can have 14 or -14 for this one. Both are correct. All right, next question. I hope you got that one. Find two geometric means between 64 and -8. All right, two geometric means. Go ahead and pause this slide, do the work, come back to the video and check it. And if you got -32 and 16. So that's the pattern. It goes from 64 to -32 to 16 to -8. Nice job. All right, next one's a hard one. These are the last two. In the geometric sequence, I want you to find for me the 7th term if I give you the 4th term and the 1st term. A lot of different ways to do this one. You could figure out what R is and then kind of use it and go from there. You could get an explicit formula for the sequence and then go ahead and use that formula by plugging in 7 for n. But go ahead and try this one. Pause the slide so you can finish your work because the answer is 2048 is the 7th term. All right, final question. In the geometric sequence, I need you to find the 8th term, given that the 6th term is -96 and the 3rd term is 12. You are looking for the 8th term. Again, a lot of great ways to do this. Maybe you want to use that generalized explicit formula and find R and then work with the terms you know from there. Maybe you want to use the generalized explicit formula, find R, and then go ahead and write an explicit formula and plug in n equals 8. Whatever way you choose, but did you get the answer of, pause it if you need more time, -384. All right, awesome job today, guys. I know this was a long lesson. You plowed through it. You did good. If you have questions, comment below, contact me. We have a live Google Hangout session coming up tomorrow where I'm going to take any questions you have on these notes. So if any of these didn't make sense, write down your questions, star them in your notes, and bring them to our live session on Thursday. I look forward to talking to you guys. Have a great day today. Bye.